And what about this series 1 over n plus 1? Converge or diverge? Well, one thing you can do is estimate, so that plus 1 on the bottom doesn't really matter. At least for an estimate, it doesn't really matter. So I could say this is approximately like 1 over n, and I know that 1 over n diverges because I've done the integral test before. And I can do the integral test here and show that it's still going to diverge. So sometimes it's good to start with an estimate and basically know, are we looking for converge or are we looking for diverge? In here, I'm looking for diverge. And that means that the sum will be infinity, so I don't even need to do that part. So let's see if I can integrate. So integrate 1 over an x plus 1. And the limits are from 0 to infinity. So this one is allowed to start at 0 since it's only x equals -1 that would make it undefined. And then this one is literally straightforward natural log. It's going to be natural log of x plus 1, and then evaluate that from 0 to infinity. And when you substitute infinity, that will be the natural log of infinity plus 1 minus the natural log of 0 plus 1. So that'll be the natural log of infinity minus the natural log of 0. And the best way to look at that is if you think about the graph of natural log, or if you don't want to think about it, I'll just show it to you. It looks like this. And right here on the x-axis is 1, which is where I realize I made a mistake. 0 plus 1 usually equals 1. I don't know why I put a 0. I think I was just trying to show you that nobody's perfect. Okay, there we go. That's what it's supposed to be. So natural log of infinity means as you watch the natural log function, where's it going? And it just keeps going up and up. It does not do it very fast, but it does go to infinity. So it's on its way to positive infinity. It keeps going up. And then for natural log of 1, well, that's where it's crossing the x-axis. So that means the natural log of 1 is equal to 0. So that means that we get, this is going to be infinity minus 0, which equals infinity. And that is definitely diverges. So by the way, diverge actually has two meanings, or two possibilities where you would conclude diverge. One is you get infinity, that's definitely diverge. The other way it could happen, and it didn't in this, but the other way that it could happen is if it basically bounces between answers, like sometimes it's 1, and then sometimes it's -1. And then it changes its mind 1, and then -1, and then 1, and then -1. That also would be diverging. So to converge, it has to have one and only one finite answer. So if the answer was 17, it converges. All right, we're done with this one. On to the next.